Hello, my name is Birring, and this video is an update of the last video on visual testing. So I'll just go through the whole process of visual testing of welds. So first step is to go to the WPS, the welding procedure specification, and that document is created before the welding begins. So the VT inspector needs to be involved before the welding actually begins, if possible. So in the WPS, you will have part number, what part it is it structural or is it piping, and the material, carbon steel or whatever other alloy it is. And then it will have all the welding parameters, the electrode to be used, the temperature, preheat, post-weld heat, and all that stuff will be there, temperatures. So for the VT, it will actually give you the bevel angle before the welding begins, and in this case it says 30 plus minus 2 degrees. So then root opening allowed, if any, here it says 0. Misalignment, maximum allowed, let's say 3/32 of an inch. So this is an example. So this is how it starts, and then the welding is done. Then after the welding, then we have to do the VT of the completed welds, and the WPS may have all the acceptance criteria here, or it may just refer to a code or a specification or a procedure where the acceptance criteria is written. So here we go to the codes. For example, it could be AWS code or ASME or a mill standard or a company's procedure or specification. So in that document, it will actually provide you with all the parameters for the acceptance criteria. Number one, it may actually define different types of welds, like weld class 1, 2, 3. So for each class, there will be different acceptance criteria. So for example, in this case, one could say for class 1, the criteria will be more stringent compared to class 2 and 3, because class 1 could be more critical weld. So then after that, it will give you misalignment of the final part. And this misalignment in the code, since this is generic, it's going to be depending on the thickness of the part. So it might, so for quarter inch, it will have like so much misalignment allowed, 25%. For half inch, for 1 inch, it will be different numbers. So you have to go to the table and find out how much misalignment is allowed for the part I'm inspecting. Then again, reinforcement will also depend on the part thickness. Obviously, the more the thickness, the more reinforcement will be allowed, maximum reinforcement. And then arc strikes, weld spatter, gouges, it will have all the acceptance criteria for all of them. And then slag, it will tell you how much is allowed or not allowed, or is it totally not accepted. For porosity, generally you will have acceptance for single porosity. It will provide you with the size depending on the part thickness. For single porosity, maximum size of single porosity allowed. And for multiple porosity, what will happen is that they will provide you with the length and the number and the total porosity allowed in that length. For example, it may say in 2 inch, you have to count all the porosities which are 1/16 inch or more. So you count all of them. So if there are 3 porosities, it's going to be 3/16 in this case. And if the maximum size allowed of the combined porosity is 1/8 inch, so 3/16 is more than 1/8, so that will be reject. Then same thing with undercut. They will be in the acceptance criteria, they will provide you with for a single undercut, what is the maximum depth allowed, and for over a length, it will also provide you, in some codes it will say, well, for single, so much depth is accepted, but if you have shallow ones over a length, then it will actually give you all that information. What is the accumulated undercut allowed over a certain length, which could be 12 inches long, that so much undercut is allowed, with depth not to exceed a certain depth. So all these numbers, you really have to go through them before you start doing the inspection. So let's go to some demonstration of the inspection on some parts. Okay, I just gave you the steps on doing the visual inspection. Now we will go through an actual demonstration. And first thing, you need a data sheet to document all your results. And then these are the basic tools. So really you don't need many items as tools. You just need a ruler and this cam gauge. It does a lot. And then you will need a fillet gauge if you're doing fillet welds, and a flashlight and your pencil or pen. So now we have not started the weld. So we are on the left side of the board there, in which we are preparing to do the welding. So that gives you like a root of bevel, angle and misalignment and all that. So let's check for the misalignment. The welding has not started, and these are some samples I have with me. So you put it here, and then from there you can actually see how much is the misalignment right there. So whether it is acceptable or not. So you put the gauge on one side and this pointer on the other side, and it tells you the misalignment. Then that's done. So now we go to the bevel angle, and before the weld is done, you would be measuring the bevel angle. You basically put it here, and I'll just show you a demonstration, and then you read the bevel angle. Right there, you will read the bevel angle. So you just line it up on the bevel and read the bevel angle and see if it is acceptable as per your WPS. Then these two parts will be put together, and then we have to see the root opening, and if any root opening is allowed, or it says 0 root opening, that means the root opening is not allowed. So now these two parts are ready for welding, and now let's say the welding is completed. And once the welding is completed, then we come over here to these parts. The final weld is complete, and this part has misalignment. Again, you put the gauge here, and then you can check the misalignment by putting the gauge on one side and this pointer on the other side. And from right here, you will see how much misalignment is there and whether it is acceptable or not acceptable. So that's misalignment, and here are some more examples. So this is an example of lack of fusion in the weld. So here I put the flashlight on, so it's more clear. So here is a lack of fusion here. So that's this one, and then let's see what this one here. This is actually a crater. So you look for crater cracks, and if the crater cracks are allowed or not allowed. And then this is porosity. This is multiple porosity. So right here, if what is acceptance criteria for multiple porosity, and how many you have to actually sum all the porosity and see if the sum is less than the total sum allowed in the acceptance criteria. So that, and then here we go. This is the weld spatter. Poor workmanship. That's not good to have. So, but I don't know if that would be acceptable or not acceptable, or you just grind it off. Then we have the undercut. So see, undercut is actually in the base metal. So that would be the undercut. And then if it says that, anything more than, let's say, 1/16 is not allowed or whatever, you can actually measure it with this gauge and putting it like this and measure the depth. And so from there you can say it's acceptable or not acceptable. But most of the time, we use the gauges only for the borderline defects. So this is very important, that we don't use the gauge. We don't use the gauges on every weld we are inspecting. With your experience and your skill level, most of the welds you can actually eyeball and say that it is acceptable or not acceptable. When you're not sure, when they are borderline, in that case you would be using these gauges to see if if it says anything more than 1/16 of an inch is rejectable and you're not sure, then you will use the gauge to verify that it's less than 1/16 and acceptable, or more than 1/16 and it's rejectable. So that's how it's done. So here is an example of another defect, and this one is lack of penetration, where the weld bead is missing. In most cases, this will be a reject. And this is concavity, where an attempt was made, but you didn't get the full root here. So you see there is a difference between LOP and concavity, and for both of them, the acceptance criteria will be different. Most likely this will be outright reject, and this will have its own acceptance criteria. This additional item is the fillet weld. The ones we just did were all butt welds. So for fillet welds are very common in structural weld inspection. So in structure, they're very common. Really, all you're looking for in the fillet weld is the size, which is from here to there. And this is given, this is the actual in the design, what size is required. And do you want to make sure that the actual weld, which is from here to there, is called the leg, that this leg is at least equal to the size. So remember, size is given is the design size, and leg is what is actual. So then we also want to make sure that the weld, the throat of the weld, which is from here to there, is more than what is in the design throat, which is from here to there. So let me just kind of give you a demonstration, and it will be more clear. So first thing, we need to know what is the size of the weld. So based on that size, we will pick up the fillet weld gauge, and they come in a range of sizes. So in this case, let's say our design size is 3/8 of an inch. So we'll pick up a fillet weld fillet gauge, which is 3/8 of an inch, and this will check the size of the weld, and this side will check the throat. So I'll just give you a demonstration, and you put it here like that. And then you will make sure that this top tip is more than, it's kind of getting lifted up. So that's a good sign. That means that's enough leg, which is more than the size. And then this line here, you can extend it to the bottom here, and make sure that leg is more than that extension of the line. And then you can go through it all over like that to make sure. So this weld has the size, or the leg of this weld is acceptable. It meets the size requirement. Then the next step is the throat. For the throat, you kind of flip the gauge like this, and you can see this one is actually for the 3/8 inch. So you won't see it when I flip it, but let's say I flip it here, or we can do it here like that. So here you see that you put it here, and we have to make sure that this tip actually touches the weld. This tip here touches the weld, and then you just kind of put it here and just move it, and it should touch it all the time, and there should not be any light coming under the tip, and that checks the throat. So it's very simple. For the fillet weld, all you need is the fillet gauges. You don't need all that measurement stuff for these gauges. So finally, what I wanted to say is that with experience and with the skill, most of the weld you can just look at it and say they are acceptable or outright rejectable. And you have to have these gauges with you for the inspection, and use them when something you're not sure is acceptable or rejectable, and it's borderline. And all you need is simple gauges, just like this one, and this one comes in various sizes. And make sure you have a good data sheet to document all your reports. And finally, I would like to say that in VT testing, taking photographs is very important. If you see, let's say, undercut, or you see porosity, you should take some photographs, examples, and include them in the visual testing report. Visual testing report should have photographs. So thank you very much, and good luck for your next inspection.